So the focus of section 4.1 is composition of functions. So we did function operations in our study guide, and we are going to do composition of functions practice here with the section 1.4 stuff. Okay, so our task here is to figure out what f of g of something is, or what g of f of something is. Okay, so this is where first you find the value of the inner function, you take that value and figure out what the value of the outer function is based on whatever, like in this case, g of 0 is. So let's do a couple examples. So we'll start with number 1. So if I have f of x equals 4x plus 8 and g of x equals 7 minus x squared, they're asking us to find f of g of 0, and they're asking us to find g of f of 0. So the first thing we want to do is figure out what g of 0 is. So this is our first step. It's a different color here. So our first step, step 1, let's find g of 0. So all we're going to do is replace the x in our g of x function with 0. So we have g of 0 equals 7 minus 0 squared. So g of 0 is 7. Our next step is going to be taking our g of 0 value, which is 7, and we are going to find f of that. So we're going to find f of 7. So f of 7 just means use the f function and replace the x with 7. Okay, so I end up with 28 plus 8, which is 36. So f of g of 0 is equal to 36. So in the other instance here, we have g of f of 0. So our first step is going to be to find f of 0. So step 1, f of 0. So we replace the x with 0. Add 8, so that cancels out. The 4 times 0 is just 0. And so now we just have 8 as our value here. Close that up. Close that up. And our second step is going to be to find g of 8. So g of 8 just means I'm going to replace the x with 8. So 7 minus 8 squared, so 7 minus 64 is going to give me negative 57. That should be it. So g of f of 0 is negative 57 in this case. Okay, so that's the basics of how we would do number 1 through 4. Numbers 5 through 8, let's go ahead and look at. So in this case, we're getting a table. This works the exact same way. It actually goes a little bit faster because we don't have to calculate anything. So if I have f of g of 8, first I want to figure out what g of 8 is. So we have g of 8 equals, well, we're going to find where x is 8. That means g of 8 is 4. So then we're going to find f of 4. So we go to 4, x is 4. Well, f of 4 is 4. Okay, so the value of f of g of 8 is 4. So we'll do another one. Let's go ahead and do number 8. So we have g of f of 3. So we're going to find f of 3 first. So f of 3 is 8. So g of 8 is 4. Okay, so what you're going to do is find the value of the function inside the parentheses, and then use that value to find the value of the function outside the parentheses. Okay, so again, with the graph, so numbers 13 through 20, with the graph, what you're going to do is look on the graph for f of whatever they're asking you for, g of whatever they're asking you for, and use that value to figure out the value of the other function. So let's do number 14. So g of 1, I'll just do this. G of 1 is 3, because the height of the line is 3 when x is 1. So that means I'm going to find f of 3. Well, f of 3 is 2, because that's the height of the line when x is 3. Okay, so input is 3, output 2. Okay, the input's always in parentheses. Okay, the last section here is our, well, not quite the last section for this video, is figuring out what f of g of x is and g of f of x is when given equations without numbers that I'm substituting in for x. Okay, this is gonna be a little bit more complicated and require a lot more simplification. So it's gonna require us to kind of think back to the previous unit and how we simplified things there. So let's look at number 22 together. It's really similar to 21. So I have f of x equals 1 over x minus 4. So 22. F of x equals 1 over x minus 4. And g of x equals 2 over x plus 4. So they're asking us to find f of g of x and g of f of x. So what we're doing is actually replacing the x with the entire other equation. So let's find f of g of x. So I'm going to put g of x in for x in this equation. So I'm going to end up with 1 over 2 over x plus 4 minus 4. Okay, so this will be our part 1 here, or A. So if I'm simplifying the denominator, so I'm going to end up with 1 over, well, 2 over x plus 4 minus 4. Plus 4 and minus 4 cancel out. So I just have 2 over x. And if we remember from our previous unit a while back, to get a fraction out of the denominator, we just multiply the top and bottom by the reciprocal of the denominator. So x over 2, and we multiply the top by x over 2. Because it's just like multiplying by 1, right? X over 2 over x over 2 is 1. And then the x's here cancel out. The 2's here cancel out. And I'm left with 1 on the bottom here, so I don't even have to write it because it's the bottom of, because 1 is the denominator. Doesn't change the value. And then I have 1 times x over 2, so I just have x over 2. That is f of g of x. So if I'm going the other way, and I have g of f of x, again, what I'm doing is I'm replacing the x in the g function with f of x. So I end up with 2 over, then in parentheses, I have 1 over x minus 4 plus 4. Okay, so this is where it can get a little bit tricky, but not too terrible. So if I want to get rid of this fraction in the denominator, I'm going to multiply that by the reciprocal. So I've got 2 over 1 over x minus 4. Then I'm going to multiply by x minus 4 over 1, and then x minus 4 over 1 on top. Then I still have plus 4. So on the bottom, these all cancel out. Awesome. On the top, I'm just doing 2 times x minus 4 over 1. Well, x minus 4 over 1 is really just x minus 4 because 1 doesn't change the value of the numerator at all. It doesn't do anything. So I have 2 times x minus 4, so I can use distributive properties. So I'm going to move down here. So I have 2 times x minus 4. The denominator's gone, which is awesome. Then I have plus 4 here. I'm going to use distributive property. So this ends up being 2x minus 8 plus 4, which in the end, if I combine the negative 8 and the 4, it's 2x minus 4. Okay, so it requires a lot of simplification. It also requires us to remember how to get rid of fractions in a denominator. Okay, so pay attention while you're working on the rest of these to some of our rules here. So what can we simplify inside a square root? What can we simplify inside an absolute value or in a denominator? Okay, how does that work? All right, so we'll go ahead and end that one there.